axis of symmetry goes down the middle, and this parabola opens down, so we'll have a U shape that opens downward. And that would be the graph for the equation. Title of the first section is Review, Finding Square Roots. In this section, we'll review finding square roots, which again is simplifying radicals. First question is square root or radical 36. If you remember, 36 is a perfect square. There's a number times itself that's 36. And that number would be 6. So the square root or radical 36 is equal to 6. Second question is square root 169. 169 is also a perfect square, meaning a number times itself is 169. And that number would be 13. 13 times 13 is 169. Next, square root has a negative sign outside the radical, and then inside the square root a fraction 1 over 9. We cannot take square roots of negative numbers, but if the negative is outside the radical, that means our answer will be negative. And if you remember taking a square root of a fraction, we can take the square root of the top number and square root the bottom number. The square root of 1 would be 1, since 1 times 1 is 1. And the denominator 9, the square root would be 3, since 3 times 3 is 9. Bringing the negative over again, the answer would be negative 1/3. Next square root is square root of 900. If you wanted to, you could do a factor tree for 900, but 900 again is a perfect square. The first digit, first number is 9. We can take the square root of 9, which would be 3. And if we have 2 zeros after that, that's kind of like a pair of zeros or a number times itself that gives you 2 zeros. And that would be 10 times 10, because 10 times 10 would be 100. And what we can do is bring over a 0 for a 10. So in this case, 30 times 30 would be 900. And last question for the section. A negative again outside the square root symbol. And inside we'll have a decimal, 0.25. Again, we cannot take a square root of a negative number inside the radical, but if the negative is outside, we can bring the negative outside. Taking a square root of a decimal, if we ignore the decimal at the beginning and look just at the number 25, we could take the square root of 25, which would be 5. Since 25 has 2 numbers in the decimal spot, for square roots we'll take half of those decimals or pair them up, so we'll have a single decimal in our answer. So instead of 5 for the answer will be 0.5. 5 times 5 would be 25, but since we have 2 decimals, we'll have a single decimal number in our answer. So our final answer, bringing the negative over, will be negative 0.5. rational and irrational numbers. The two definitions. Rational is a number if you can find a perfect square. So a number where you can find two numbers that equals the square root is a perfect square, and that would be rational. Irrational is if you cannot find a perfect square, meaning you cannot simplify the square root without doing a factor tree. There is no number times itself that equals the square root. Title of the next section is State, Rational, or irrational. In this section, we'll look at square roots and determine if they're rational or irrational square roots. First question is the square root of 16. Looking at the square root of 16, if you wanted to, you could simplify this. The square root of 16 would be 4. And since we can find a perfect square or an answer to the square root of 16, that means the square root is rational. Second question and second square root. Have a negative outside the square root and inside the number 20. Looking to simplify 20, there is no number times itself that's 20. So again, if there is no number times itself that's 20, that means 20 is not a perfect square. And if it's not a perfect square, that means it's irrational. Next question. Again, we have a negative outside the square root symbol. Inside is a fraction, which is 4 over 25. Looking at the fraction 4 over 25, again, square roots, you can think of two separate problems. The square root of 4, if you wanted to, would simplify to be 2, since 2 times 2 is 4. And the denominator 25 is a perfect square, which would be 5. The negative you can also bring over. So 4 over 25, since we can simplify both numbers, 4 and 25, that means the fraction is also a perfect square, which means the fraction is rational. And last question for the section. Square root of another fraction, which is 1 over 6. Again, trying to simplify this fraction. The numerator 1, if you wanted to, you could take a square root of, which would be 1, since 1 times 1 is 1. And the denominator 6, there is no number times itself that equals 6, so the square root of 6 would stay the same. When you have a fraction, if one or both of the numbers cannot be simplified or is not a perfect square, that means the original fraction or the original square root is irrational. Both numbers in a fraction have to be a perfect square for it to be rational.